Okay, so today we are going to look at how we can simulate circuits, build embedded systems online before we translate that to the physical components. As far as robotics is concerned, the main idea behind robotics is the robot needs to understand what is going on in the environment and then take a certain action. It uses sensors to understand what is going on, then uses actuators to carry out that action. But these sensors and actuators are connected to the brain, which is the microcontroller. So I'm going to share my screen. Okay. I'm going to try again. Yep. So you should be seeing Google Chrome. And like I told you, we're going to be using an online simulator, which means you don't need to install it. All you need is a steady internet connection. Now, the online simulator, the name of what we are going to use is called Wokwi, right? Wokwi, W-O-K-W-I. Now, Wokwi is the online simulator we are going to use, and it's quite interesting. So you just search for this, right? And when you search for it, you will see the interface as it is, right? Well, you can see the first thing, Wokwi, the world's most advanced ESP32 simulator. So you just click on this and it will load. So we'll give it time to load and it will bring you here, right? Simulate with Wokwi online. So the good thing about this is you don't need to install anything on your computer. So maybe if you're having trouble with issues regarding memory, or maybe your RAM isn't big and you feel it will slow your system down, then you don't need to do any installation. Like the computers in the lab also, they could be a bit slow, particularly if you install heavy simulators. So in instances like that, you can just get your internet connectivity and do the simulation online. Now, from what you can see here, you can see you have the Arduino Uno, the ESP32, Pi Pico, this is Raspberry Pi. You have different variations, right? But basically what we are interested in is we are going to use Arduino Uno because this is the main microcontroller we have in the labs. ESP32 is also similar to Arduino in terms of coding, but ESP is mostly used for Internet of Things projects where you need to transmit data over a network or so. Then you have the Raspberry Pi. This is based on Python and the STM as well. But we are going to go with Arduino. So I'm just going to click on Arduino Uno, right? And it has brought me here. Now here is you choose different, these are just featured projects. When you open them, they're already done. So you can just open any of them that will that you want to see how it works. But in our case, we are going to start from scratch. We're building this from scratch. So you can choose Arduino Mega, you can choose Arduino Nano and the rest. Uno is smaller than Mega, but it's bigger than Nano. We are going to work with Uno because that's mostly what you have in the lab. So I'm going to click on Arduino Uno. All right, so this is one thing I like about Wokwi, right? On the left-hand side, you have where your code is. On the right-hand side, you have the circuit setup. Normally, if you are building a robotic system, number one, you have to write the code. When you write the code, you send it to the microcontroller that this is what I want the code to be doing. Now, when you write this code and send it to the microcontroller, then you connect the relevant components to the microcontroller and you turn it on, right? So there are many problems with this, right? Number one, how would you know your code is working, right? How would you know your code is working when you just write the code? So when you write the code and you send it to the microcontroller and there is an error in the code, or it doesn't compile, or it compiles but it's not working the way you want it to work, what happens? It means that you now have to go disconnect the microcontroller, go back to the code, recode again, correct the code, and send it. So you keep doing that until the code works. Then also the same thing with your connection. So if you continue doing that, there is a tendency that you may damage the microcontroller. You may damage the components that you are working with, right? Always connecting, disconnecting. If there's a power surge, a component can burn. And what happens if you burn the component, right? You have to buy another one or you have to use another one. So this is why simulation is important. With simulation, you, particularly with this, you do the connections here, you do the code here. If there is any error, it's on the simulation. You correct it on the simulation. Once the simulation works the way you want it to work, then you are good to go, right? Are we still together? Can you still hear me? Just give me a thumbs up, or you can just unmute yourself.
Yes, sir.
Aha, good. Okay, good. So now from here, let's start with the simulation part, right? All you have here is a space. You put your components, you can move the components around. Here, this plus button is where you add a new part. So any component you want to add, you can just search for it here and you add it, right? So assuming I want to add an LED, I click on LED and the LED is added. I now bring it anywhere I want here and I keep it, right? Now, here is just options. You can debug, undo, zoom in, zoom out. They're just options for working. Then this green button is for you to start the simulation. So when you finish all your connections, when you finish everything and the coding, you just click on the green button. It will run the simulation and you will see how it behaves. Now, please, if you're not talking, kindly mute yourself. I have muted you, but some of you are unmuting. Okay. Now, on this left-hand side is where you have the code, right? Let me see if I can. Yes, okay. Right. So on this left-hand side is where you have the code. You have the code on the left-hand side. This code is what you put on the Arduino. So in reality, you will have to download the Arduino IDE, write the Arduino code, send it to the Arduino, then you do the connections and it works. But here you can just do the code here and run it and you will see. So this sketch.ino is where you do the code. The .ino files are the Arduino files, the Arduino code files. So anything you want to do for Arduino, the coding will be .ino. This diagram JSON is just to show how they are connected. So you don't really need to touch this, except if you want to arrange it using code, which is quite stressful, then you come here. Then library manager is if you want to add any libraries that you don't really have, but we are not using that for. What we are going to do, right, is we are going to write a code that controls a LED, an LED, a light that blinks. So we are going to write a code that makes the light. Okay, sorry about that. I lost my network for a second, so let me still reshare. Okay, so I think we are back. So as I was saying, okay, as I was saying, we are going to write a code where we're just going to collect an LED, right, which is a light emitting diode, just a light. We are going to make it blink on its own, and we're also going to make it blink when we push a button. Then in the subsequent sections, we are going to do maybe something a bit more complex, like controlling a DC motor and things like that. So the next thing you need to keep note of is the code, right? There are two parts of the Arduino code. You have the setup, which is the first part, and the loop, which is the second part, right? Setup means this is where you will define, because if you look at the Arduino, let me zoom in, you can see that there are various pins, right, where you can put in your jumper cables. And each of these pins have numbers. So any pin you are going to use, you need to define what the pin is going to be doing for you. Am I using the pin to take in input from a sensor? Am I using the pin to give out output to an LED? Am I using the pin to give output to a DC motor? Am I using a pin to give output to a display, a screen? So in the setup, you define what your pins are doing. And then in the loop, which is the second part here, you write what the code is going to be doing, because when it's looping, it will just keep doing it until you turn off the Arduino. That's the way embedded systems work. When you turn it on, what is in the loop will keep running repeatedly, right? Until until you turn it off. Are we? Are we together? Can you hear me? If you can hear me, just give me a thumbs up. Okay, good. So you can hear me. All right, so let us first do the code that will run the LED, right? This is my boy. Sorry, just a minute. Hello. Okay, sorry about that. So we are going to write a code, right, that makes the Arduino, makes the LED blink, right? So that's what we are going to do. Now, LED, like I said, is a light emitting diode. LED is a light emitting diode, right? So how do I put the LED here? I come to this plus button, add new part, and I click it. I am hoping some of you are on your computers that are following. If you are not on the computer following, just pay attention and take notes. I will share the recording afterwards. I'll put it in a way that is accessible, maybe on YouTube or Google Drive or something. All right, so I'm going to add this LED, right? This is the light emitting diode. When you click on this plus, there are many components here that you can add, right? You can even search for them. I can type LED and you can see there are different types of the LEDs, but I'm mainly interested in this main LED, right? Sorry, I click it and it has been added, right? So when you add it, it's here. Now, I can change the color of the LED. When you click on the LED, this bar will come. So it can be green, it can be yellow, it can be orange, it can be purple, it can be any color, right? So let me see who is paying attention. I'm just going to call somebody at random to give me a color, right? Dominion, are you with us? I like the name Dominion. So let me see if Dominion is actually with us or they just joined and disappeared. Dominion, are you with us? So it's like Dominion isn't paying attention. Let me choose another person at random. Usman Suraj. And I'm taking note of the I'm calling. Okay, good. So Usman is here. Usman, what color should we put?
Let's use green.
Is it green number 1 or green number 8?
Green number 8.
Okay, good. You can mute yourself back. Thank you. So let's go with green, right? So the LED is going to be green. So basically what we are going to do is now connect the LED to the Arduino, right? Now, the LED has two parts. It has two legs, like the legs you use for running, one leg and the other leg, right? If you remember your basic circuit in secondary school or primary school or whatever, one leg needs to go to the positive, right? And the other leg needs to go to the negative. Are we together? One leg needs to go to the positive and the other one needs to go to the negative. So we are going to make one leg connect it to a positive terminal, and we are going to connect the other one to a negative terminal. So this is what we'll do, right? If you look at the Arduino, I'm zooming into the Arduino now so that you can look at what I'm telling you. You will see that here we have GND, right? We have GND here. We have two GNDs here, right? Anywhere you see GND, it means ground. It means ground, and that is your negative terminal. Anywhere you see GND, it means ground and it means your negative terminal. It means one of your legs in any component you are connecting must go to ground. It must go to the negative terminal. Now, the positive terminal can be any other thing here. It can be 13, 12. It can be any of these numbers depending on the type of device you are using, okay? So one must go to any number and the other one must go to ground. Now, this LED is a digital device, right? Because it just takes, it can use a DC current to work, right? It's mostly a digital device. So what I can do is I can connect one terminal of the LED to ground, and I can connect the other terminal of the LED to maybe pin 12. And I have made the connection, one to ground, one to pin 12. So the one going to ground is negative, and the one going to pin 12 is positive. Now, there is another thing you need to do. If you connect the positive directly to the pin, there is tendency that because the flow of current or maybe a power surge or something, it could damage the LED or it can damage the pin, the Arduino. So what do I do to minimize that, to help with that? I add something called a resistor. So I'm going to disconnect this, right? And I'm going to add a new part and I'm going to add a resistor. And the resistor has now been added for me. Now, a resistor can take many values. A resistor, the values are measured in ohms, right? Ohms. It looks like the omega Greek symbol. So when I click on the resistor, it's asking me what value of the resistor do I want. So you have to put a value that is high enough to restrict the movement of current, but not too high that it will block the current completely. So I will just use normal ohms, not kilo ohms or mega ohms, and I'm going to put 220. 220 is just a standard resistance value that works with LEDs, right? So now my pin will go to one pin of the resistor, and the other pin of the resistor will now come to 12. So instead of me, connecting it to the this thing directly, I will connect it through the resistor. So you can the connection now, you can see how it is. The negative terminal is connected to ground, and the positive terminal goes through the resistor to the microcontroller. Now, which pin on the LED is negative or positive? It doesn't matter, right? Either way you connect it is fine, but you only notice the difference at the point of running the code, because sometimes if the polarities are reversed, then where you are putting high, you change it to low. So let's leave it at this. So with this, we have connected the microcontroller to the LED. The next thing is to make the LED blink continuously, right? First, we are going to go to the setup here. Now, the code we are going to put in the setup, we are going to put a command called pin mode. P is small letter, M is capital letter. I'm sorry, it's like you can't see my screen anymore. I just noticed it went off. Let me reshare. Okay, and I think you should be seeing my screen now. Yes, it's back up. So pin mode is what we are going to be using, right? Pin mode means you are specifying what mode of the pin, what that pin I'm using, whether it's 12, 13, 1, or 2, what mode is it? What role is it going to play in my simulation? What is the function of that pin in my simulation? What is the use of that pin in my simulation? So the pin mode takes two parameters, right, inside the bracket. The first thing is you put the number of the pin. In this case, we are using pin 12. So I'm going to put 12. And what is 12? So you can make it either input or output. But because I am sending information to the LED, I am not taking information from the LED, I'm going to make it output. So pin mode, pin 12 is an output pin. That is what I am telling Arduino. And you have to do this in setup because that is where you are defining how it will work. So pin 12 is an output pin. That is what this means. And what I have here with the 2/ is a comment. It's just a way for you to put notes on your code. The comment will not run, but it's there so that it will help you understand your code better. So all I'm saying here is that pin 12 is an output pin. Now I am done with setup. What is the next thing I'm going to do? I am going to come to the void loop. I don't know why this thing keeps going off. Okay, I have reshared it. So now I am going to the void loop. I am done with the setup, right? I am now going to the loop. Loop is what will the code be doing continuously. It will be doing this over and over and over and over again, right? So I am going to use a command called digital write. So I'm going to say digital write. The D is small letter and the W is capital letter. It means, remember, if you look here, 12 is connected to the digital part. There is digital part, there is analog part. We are connected to the digital part. So we want to write to the digital. If you are reading, it means you are taking information from it. If you are writing, it means you are sending information to it. So digital write, what am I writing digitally? I am writing to pin 12. And what am I writing to pin 12? I am writing it to be high. Now, when you send this to pin 12 and you write it to be high, it is expected that the pin will bring out light. It will bring out light. But now, because this thing is a computer, all right, computers process information very fast. In milliseconds or in seconds, they process the information very fast. It will send a command here and we will not see what the command is if we want it to blink. But for now, we have defined that pin 12 is output in the setup. In the loop, we've sent the digital write to be high. Let us run this and see what happens. So what do? I come here and I click on the green button to start the simulation. So it's running. it's telling me that the build has failed because there is an error in my code. So whenever you have an error in the code, the build will fail. If you were not simulating and with this error you sent it to the microcontroller, you will just see it not working. And that is why simulation is important. What is the error? At the end of every line, I have to put a semicolon. So hopefully now with this semicolon, my building will run. I'm going to save this. Oh, I've not saved it. So let me call this LED_blink. All right, so I'm going to, okay, it has reloaded. So I'm going to start the simulation again. And you can see that my LED has brought light. Can you see it bringing light? If you can see it, put a thumbs up. Good. So all I did was I defined my pin 12 to be output, and I have defined that it should write a high signal to pin 12. Now it is just bringing light, it's not doing anything, Adi. Let us assume I want to make it blink, go on and off, on and off, on and off. What do? I come back here, I'm going to stop the simulation. Now you see that the light has gone off. To go on is high, Adi, and to go off is low. So all I'm going to tell it to do is high and low, go high, go low, go high, go low. So I'm still going to use my digital right. I'm still going to use pin 12, but instead of high, I am going to put low. Now, the problem with this is that it will be going high and low so fast that we will not see it with our naked eye. It will not see anything happening. So we have to put a delay to say if you go high, wait for this number of seconds, then go low, wait for this number of seconds, then go high, wait for this number of seconds, then go low. So after here, I am going to put a command called delay, just delay, right? And what delay does for me is it will delay, but this delay is you put the number of seconds you want it to delay in. Now this delay is in milliseconds. So if you put 1, it will not delay for 1 second though, it will delay for 1 millisecond. If you want it to delay for 1 second, you put 1000. 1000 milliseconds will give you 1 second. When I come to the digital right, low, I'll also put a delay and I'll put 1000. So what does this mean, right? It will write high, it will come on, it will wait for 1 second, then go off. It will come on, wait for 1 second, go off, wait for 1 second, come on, and it will continue doing this. So let me save this and let me run it. I also have another error. What is the error? I did not put a semicolon after the delay. So whenever you have errors like this, you need to fix them before it runs. So I'm going to run again. And as you can see, my LED is blinking. Is it not? Oh, sorry. Okay, I think I'm back. It should be blinking. I wanted to come back to the browser to see if it's actually blinking. But from my browser, it looks like it's not, it's just off. I did it from my browser. I think it's from my browser, but from the code it's blinking. It should be blinking. It's blinking. Okay. So, all right. So this is just a simple LED blinking, right? We've made it come on, we've made it go off, we are going to make it blink. We are making it blink. Now, we are going to do one more thing before we put an end to it, because normally, if you want to control devices, there's usually a button, right? So you put the button, and it is from that button you will now see it. When you press the button, it will go on and off and so on. So let us try working with the button and see if we can control the blinking with the button. Sorry, just a minute. Somebody is trying to join. Okay. So just a minute, please. Okay, so we're going to try something. I'm going to stop the simulation. Now, what I want to do, sorry, let me undo. What I want to do is I want to connect a switch, right? I want to connect a switch to I want to connect a switch to the microcontroller such that when I connect the switch and we press the switch, then it will, when I press the switch, then it will start blinking. And when I put off the switch, it will stop blinking. Okay? So I'm going to come here. Okay, somebody is trying to join again. Okay. So the first thing I'm going to do is I'm going to add a new part, right? I'm going to add a switch. So let me just type switch. I'm going to use a slide switch and I'm going to bring it here. Let me move this a little. So you can adjust your lines, but mine has, sorry, mine has scattered. So let me just go back to where it is and move the switch. I'm going to bring the switch here. Now, what you're supposed to do is you see the switch has 3 legs, right? The switch has 3 legs. One leg needs to go to ground. The other leg needs to go to a digital command, and the other leg needs to go to 5 volts. That's the way the switches are connected. So one leg will go to ground, one leg will go to 5 volts, and the other will go to a digital. So this first one, I'm going to take it to one of the ground here. This second one, I'm going to take it to the 5 volts here. And this last one, let me take it to 2 and put 2. So I'm trying to make it. All right, let me just leave it like this. Okay. So the next thing I'm going to do is I have connected the switch. So the idea is whenever I click the switch, it will start blinking. Whenever I click the switch, it will stop blinking. Now I'm going to specify that this 2 that I connected is an input because it's going to take input from the switch. It's going to take input from the switch. So I'm going to say pin mode. Sorry, this is a mistake. Pin mode, right? And I'm going to put 2, comma, and I'm going to make it input. So you can see LED was specified as output because we are sending information to the LED, but pin is now specified as input because we are taking information from the switch. Okay. Now I am going to come to the loop. What do I want it to do when it comes to the loop, right? The first thing I want it to do is I want it to know whether the switch is on or off. I want it to know whether the switch is on or off. So I'm going to use something called digital read. Now you can see we are not using digital write in this case, it's read because we are reading from the switch. And I'm just going to put the 2. These 2 that we connected, read from it. what is happening to it. I just want you to read it. Now, when it reads it, I want us to store it somewhere. I want us to store it in something called a variable. A variable is just a memory location that stores the information so that we can always go back to the variable to check the information. So I'm going to call my variable switch state, and I'm going to say anything you read from pin 2, put it in switch state. Okay, somebody is trying to join. Let me admit the person. Okay. So anything the person is, anything you read from the pin 2, assign it to switch state. But because this is similar to C, we have to define what we call a data type. Do we want the input to come in as a whole number? Do we want it to come in as a decimal? Do we want it to come in as a letter? It will come in as a whole number, so we'll specify it as int. So int switch state, we want our switch state to read what is in this pin. So it's either it's going to be 1 or 0, right? Or high or low. Whatever it reads from here is what it will assign to switch state. Now, when we do that reading, the next thing is we want it to blink. If the switch state is high, if the switch is on, make it blink. If the switch is not high, do not make it blink. So it's just basic conditional statements, if else. I don't know how far you guys have gone in your programming courses, but there is something called condition, right? It's just like, okay, you carry 1,000 naira and you want to go to the market and you want to buy either apples or bananas, but you want apples. So you can say if the apples are not up to 1,000 naira, buy the apples. But if there are more than 1,000 naira, buy banana. So similar things, we do conditions in programming. If one condition is met, do A. If another condition is met, do B. So we are going to come here, right? Okay. Okay, I thought somebody raised the hand. I heard a sound. Okay. So we are going to do the condition statement, right? So we're going to say if okay, good luck. Can you go ahead? Do you want to ask a question? Or was it a mistake? Okay. All right. So we're going to say if the switch state is equivalent to high, right? If the switch state is equivalent to high, then it will do all of these things. So it is only when the switch state is equivalent to high that it will do all of these things. Remember, there is a difference between 1 equal to and double equal to. 1 equal to means you are assigning a value to a variable, but 2 equals to means you are using it to check a condition. Is this equal to this? That's the difference. So if the switch state is equal to high, then you open a bracket, a curly bracket, and all of these things will happen. So all I'm saying is if the switch state is on, do all of this blinking that it did originally. What of if the switch state is not high, right? What of if it's not high? So the opposite of if is if a condition is not met, then you use else. What happens if the condition is not met, right? So I'm just going to say else, and I'm going to open its own bracket in the else, digital write to pin 12, make it low. So all I am saying here is read pin 2 that we connected the switch. If the switch state is high, that means if the switch is on, blink the LED, wait for 1 second, remove the blinking, wait for 1 second, and you keep doing this over and over again. Or else, that means if this is not high, this is low, just make the LED off. Now we're going to run this and see what happens. So you can see it's blinking because my switch is on, right? You can see it blinking because my switch is on, and that is why it is blinking. So let me go back and turn off the switch. I'll turn off the switch by just clicking the switch, and the switch is off, and you can see that the LED is now off. I'm going to turn the LED on again, and you can see that it has started blinking again. So basically, this is what we want to cover today. We've seen how to make the LED blink normally. Then we are now seeing how to make it blink by using a switch. Now, for some of you, you might say, this is too basic. What is robotics about putting on light with switch and off? No, that's not. This is the fundamental foundation, right? Imagine the most complicated robot that you have. You need to turn it on with a button, right? When you turn it on with a button, something happens. The robot does something. If you are controlling it with a joystick or with a control pad or whatever, when you press a button, something must happen. It might be that maybe it will bring out light, maybe it will make a sound, maybe it will start moving, things like that. This is the underlying concept. You need to know how to read the information from the button, and you need to know how to send information to this. And now we are using a LED here, but it can also be a buzzer where it will make a sound. It can also be a DC motor where it will start rolling. It can be a servo motor where it will move at a certain angle, especially if you want the robot to walk. If the robot is like in a car format, sending this signal to a DC motor will make it roll and it will make it start moving. So this is the underlying concept, and the code, depending on the complexity of the operation, would only get more and more complex from here. So this is just the underlying concept on how you can read information from a switch and send information to an actuator. And that is what we are going to cover today. So do we have any questions? Please, if you have any questions, you can raise your hand. I will call on you and you can unmute yourself. Okay, so it seems there are no questions. So what I'm going to do for you, I'm going to send some things to the platform. Okay, Adam, please go ahead.
So what language is it used to build the topic we have covered today?
Okay, so the programming language we've used here is the Arduino programming language. But the Arduino programming language is based on C. So this is just, everything we are doing here is just like C, but it's packaged in the Arduino language such that you can, so if it was just normal C we were doing, this pin mode, we need to go somewhere and define what pin mode is. We need to go somewhere and define what digital read is. We need to write the code and define what digital write is. We need to write a code and define what delay is, right? But Arduino has packaged it in such a way that all this pin mode, digital read, digital write, already they've defined it in their Arduino structure. So Arduino is a separate language on its own, but it's based on the C programming language. So it is Arduino we've done, but Arduino is based on C. I saw Suraj raising up his hand. I don't know if you also have a question or it was an accident. Okay. So as I was saying, I'm going to send some things to the platform. Number one, I'm going to send this code, right? I am going to send the code for the normal blinking, and I'm also going to send the code for the switch blinking, okay? What I want you guys to do is, your own free time before our next session, go online, visit this Wokwi, and try doing everything we have done on your own. I'll send the code to you. Try it and understand what it does. If you have any questions, please just post it on the platform and I will answer you on the platform. You don't need to send me a private message. just post your question on the platform so that if I answer it, other people will learn from your question. And if you're able to do this successfully, I want you to take a screenshot of what you've done and put it on the platform as well so that we can see it. And that will encourage other people to do it. And I'm going to, once the meeting is over, I am going to share the recording with you. The recording might be a bit big, so I might not be able to put it on WhatsApp directly. So it's either I put it on Google Drive or I have a YouTube channel where I upload these videos for tutorials. So I will just maybe upload it on YouTube and share the link with you. Okay, can I reshare the link of the platform? Okay, so just give me a minute. I will share it with you shortly. All right, so but basically I will share the resources with you and you can try this on your own. And if you have any questions, you can join, you can ask on the platform. So I'm just going to, give me a minute. I'm going to stop sharing now. Sorry, I'm going to stop recording.